Yeah, it's on the bottom. There's gonna be 7 0.
No, but it's like 1 minus R, or 8 1 minus R.
That's smaller and smaller. Over something. Oh, actually.
How are you supposed to do something like this? Just ask Lydia, I know. I know. You can't always ask Lydia, she's not always here. But how are you supposed to do it? Yes, Ria?
Oh, yeah, okay.
Yeah, what do you recognize here?
It's, Virgin, right? Is that the one?
Okay, okay.
Geometric.
Is it geometric? Okay,
In the multiplying every time by 6 sevenths and A1 is 0, so you do 2 over 1 minus 6 sevenths, which is 7 times 2 is 4.
7 times 2 is 14? Are we sure about that? Sorry, that's 7 times 2 is 14, yeah, really? You sure? And that's today's date? Okay, I'll consider not giving you the target that you definitely deserve.
Well,
Since you did so beautifully with it. Okay, nicely done. Okay, quick question. If you drive 220 miles in 4 hours, what is the math question that follows? Okay, what is the answer to that question?
Yeah.
55 miles per hour. All right, so you drive 220 miles per hour, 220 miles in 4 hours. So what's the question? What's the average, your average velocity, maybe your average speed? You weren't definitely going 55 miles per hour the whole time, correct? There's probably some time that maybe you stopped, which means you had to go a little bit faster and slow down, but the average rate of change would have been 55 miles per hour. And one last thing before we start on the packet today, would you just discuss with the neighbor the difference between speed and velocity? Speed and velocity.
So like if you're going in like a positive direction. Negative direction, it's so negative. There's this negative velocity, but not negative speed.
Okay, so would like to remind us or tell us if we haven't heard? I think we've spoken about in this class, the difference between speed and velocity. Okay, Levi?
Velocity has nitrogen direction.
Are we good with that? The magnitude and direction means you can tell by the velocity if it's moving forwards or backwards, as opposed to speed, it's just moving. Thank you for that nice answer. Since it was so nice, I'll consider not marking you tardy. You're well-deserved tardy.
I mean, I don't think.
Oh, nice.
Jimmy, I'll give you a chance a little bit later. Okay, but let's get to back to the packet. Today is our last day of content.
What?
It's our last day of content today, right? Of the year. And after this, we have a flex day and then review. No, not the flex day, but flex in this unit, just we put in an extra day to account for the fact that you were going through AP exams, that the people may have been missing, so it's just kind of a chance to catch up. Sure, yeah, of course. Yeah, of course. So that's next time. And then is our official review. So I think both days will just be review. Yes, Eileen? Pardon? Oh, we do have class though. It's not like a school class day.
Does it mean that you're moving?
No, the test already accounted for that. So next time is a non-structured day. Then Tuesday, let's check the calendar. Check the calendar, thank you. Alright, so we're here today. This is, come on. This is Wednesday, so this is Friday, so this is what, Tuesday? And then Thursday. So it's as planned. Okay, so let's get to it. Now, I know in your homework you saw something like this, and I apologize for not getting to this in class, but hopefully you had some time to discuss it. I'm gonna give you guys a little time to talk about this, but what I do want to say about this T naught, even in your book, I think it gave you some crazy stuff for those of you who delved into it and really tried to make this happen. I appreciate it. But usually T naught is just equal to 0. So let's do it as if it were that, even though I understand for your homework you can't, and I wouldn't blame you for just kind of, is there a way to get through an answer without actually answering it, like to get to the next part in a multi-step? And did it force you to do it if you do that, or?
Yeah, it's like the same step, like you kind of like plug and try, but with an example, and that's not
Okay.
like.
I encourage you to just get through that. And we'll go through it with T equal to 0, T not equal to 0 today. But take a moment just to go ahead and discuss how you would do these problems. These questions.
Talk Andrew.
Actually, maybe just talk about it.
Oh,
We'll do it together.
Yeah.
Talk.
Yeah.
Yeah, it's like, or you can tell you're like,
So I'm thinking higher than.
I think, yeah, but I think for this one, I'm one that really, it's like, I think that's. I think that's a big problem.
That's just I don't want to. Well,
Like, the last, like, you're alone for people to hear. That's a long one. Like, whatever, we got it. Yeah. That's like, that was fine.
One more minute.
That's good. I was like, I was then you can find this one for yeah. Yeah.
It seems like you're right, it's only 30 seconds, but okay. Cool.
Okay, so I hope the setup makes sense. S represents the height of the ball after time t in seconds, I believe. Okay, so when does it strike the ground? All we have to do is set the equation equal to 0. Did you do that, or would you have done that? Let's go through this one at a time. So one, I think there's not enough room to write here, is there? I tried to make 2 different columns, maybe, and make it happen. And that picture is really getting in the way. I'm just annoyed by the formatting here, but I'll get over it with enough counseling eventually. Negative 16t squared plus 80t plus 96 equals 0. And to solve that, should I use a quadratic formula? I could, but that would really be overkill. Instead, first thing I'm going to do is factor out the negative 16. If the leading coefficient is negative, please make sure to factor that out along with the rest. And it just so happens that coincidentally, 16 goes into each one of these. And now that factors minus 6 plus 1 equals 0. So t equals 6 and negative 1. Negative 1, of course. Get rid of it. It just doesn't make sense in the context of the problem because we can't go back. All those things you regret, gone. Yeah. Okay. Number 2. At what time t will the ball pass the roof on its way down? In this case, we'll take the equation and set it equal to 0. Not 0, set equal to 96. I think that it says it's 96 feet high. So do you mind if I just start one step into it and say 16t squared plus 80t equals 0? Are we comfortable with that? And then same thing, we'll factor out the negative 16t in this case, leaving us with t minus 5. So t equals 0 and 5. And do both of these answers that we got in number 1 kind of make sense with the 2 answers in number 2? Right there, just 1 second before, 1 second after when it reached that height of 96. Everything is falling into place. We still can't use the negative 1, not much you want to try. Average velocity. In order to know average velocity, we need to know 2 things. What are those 2 things? The distance that it traveled and how much time it took, right? But just like that problem I gave in the beginning. So 220, divide that by 4. So how are we going to figure out how far it went? Well, we'll see where it began. We need to know S of 0 and S of 2, don't we? This is asking for from t of 2 to t of 0. So I think that S of 0 is equal to 96. Did I get that right? And S of 2, should I use synthetic substitution? No, that seems like overkill. Negative 16 times 4 plus 160 plus 96. Did I get that right? Which equals 192. 192. Okay. So to get the average rate of change, I'm going to take this 192, and I'm just going to go ahead and mark that in general form. So we have 192 minus the 96. Divide that by 2. 192 minus 96 is something like 96. So 96 divided by 2 is 48. 48 pounds? 48 feet per second. That's the average. So was it going 48 feet per second the entire time? No, any of you who have thrown something know that it probably started faster, right? And when s equals 0 than it was when it ended that time interval. So you may not have followed this, but I hope that, and even if you did it intuitively, I hope that the process makes sense to find the distance with s of the second one minus s of the first one. S being the height. And then 2 minus 0 just to kind of show you that it doesn't matter where you begin. It's just a difference of beginning and end times to give that total time. Yeah. Number 4, instantaneous velocity. How are you supposed to find an instantaneous velocity? The formula of the derivative or the slope of the tangent line. So that's what we're doing here. Went from an average velocity. This is what this arrow that's pointing here. That's the slope of a secant line. We want the slope of a tangent line. So for 4, and this is so poorly placed, I'm going to take that s of 2 and subtract from that s of t and put that over. I'm sorry. Is that what I'm doing? I think it's backwards. S of t minus s of 2. My bad. Over t minus 2. And what do I have to do to that? Take the limit as t goes to 2. Yes. Oh, thank you. Yeah, I skipped to 5 accidentally. So here it's going to be s of 0, t of 0. Thank you. Good catch. And I think that your book talked you through it to keep that t naught, which even when you get to next year, like after you gain familiarity with this, that's a ton of algebra to do, and it just gets you into this mess of notation. So you wouldn't expect anything like that on the test, neither the unit test nor the final. So like putting like a t naught into there, don't worry about it. I think it would be reasonable if it mentions t naught to say just t equals 0, unless it's an interval from 10 seconds to 30 seconds, then t naught would just be 10, whatever that the beginning of the interval is. But unless otherwise stated, you could assume that t naught is 0. So from here we have the limit as t goes to 2 of s of t, which is that guy, negative 16t squared plus 80t plus 96 minus the height at 0, which is 96. Did I do something wrong? 0. Thank you for keeping it consistent. As t is approaching 0, find the instantaneous rate of change at the initial time. In other words, when the ball, is this the ball? Yeah. When the ball left the hand. Okay, the 96 cancels out. Should I plug in a 0 now? I could, but we'll be left with 0 over 0, which always has to be fixed. Here, pretty easily fixable. I just cancel all the t's, so we're left with the limit as t goes to 0 of negative 16t plus 80. And now we plug in 0. So we get it's negative 16 times 0 is 12. Is it 80? Did I do that right? Okay. Getting about the 12. Okay, for 5, you do the same thing, but with t equals 2. So instead of zeros, you put 2 everywhere. Did you already talk about number 6? Take a moment to talk about number 6 specifically. In words with your neighbor. And if you already talked about it with your neighbor, just turn around and talk to other people we haven't talked to yet.
I don't know.
It's like saying.
Yeah.
So 6, what's the key here? Are we good with that? Something's wrong, you know that in between going up and falling down. It has to stop. How long has it stopped? For an instant. For an instant. Right, just stop for an instant and then. So when is velocity of the ball equal to 0? How should we figure that out? It's a maximum. Know that the function we're looking at is parabola, so we have to find the vertex of the parabola. And we do that by see that t value would be negative b over 2a. That's going to give you the time that it got up to the top. You want to know exactly how high it was, and you would plug in that time. Does that make sense? That it's dependent on the vertex? We're not going to do 7 and 8, 7 and 8. But what do you know about the answers? Since it's talking about velocity on the way down. It'll be negative, isn't it? And how do you think it's going to compare, like the one passing the rooftop on the way down, compared to the initial? The initial is 80 miles per second going up. Probably negative 80 when it passes that same moment. So maybe you don't even have to do calculations there. The only other one you'd have to calculate is that number 8. Would it be just 0 because it hit the ground? It's 0 after it hits the ground, but that impact, like how fast is it going? You'd have to do that same. That's prime of 6, I believe. It hits the ground at 6 seconds. Are we good? I hope that this made sense. I hope it helped. And if you struggled with this already, thank you for the time and effort that you put into it. I'm sorry we didn't get to this yesterday, but you can see that trying to squeeze that into the last couple minutes of class would not be pleasant for anybody, nor I don't think effective use of your time. The last unit. Here we go. I'm just gonna do some scratch paper and give you some ideas first before we actually do this problem. One thing they're going to ask you to do next year is to find the area under a curve. And it starts easy. Like if your curve is a constant function and you're going from like 2 to 8, and this is, I don't know, y equals 7. Do you see what the area would be? Or from 2 to 8, that means we're blocking off before and after, and now it's just 6 times 7. It's 42. Easy. Okay, of course, it's not going to be that way all year. Sorry. But it turn up the fire incrementally. Let's say this is y equals, let's just do y equals x. Y equals x. I ask you to find the area from 0 to 10 under this curve. That'd be difficult. You would, if it was just the area of a triangle, yeah, it'd be. I'm gonna give you a moment to actually work this one out. What if we're going from 2 to 10 here? We're looking for this area. I want to take a moment to discuss with the neighbor how you would do that.
Oh, yeah.
It is white was yeah. So yeah, I forgot to emphasize this is y equals x for sure. Or it could be any function if it's y equals x. And did you get a number? What's the number you got? 48. Are we good with that? Would like to explain how they got it. Lydia? Too bad you weren't late today, otherwise I'd excuse you right now, but you were on time like always.
Well, I just like found the area with the bigger triangle first one.
Yeah, 48. Can we do it a different way? Thank you. Can we do it differently? Is that how you operate? What are some other ways? Hold it down. So wait, is this a trapezoid? You said if you want to find the area of a trapezoid, you can split it into a. Like then to split it, you're gonna make a cut that goes in this direction. Okay. So it looks like you're not thinking about this as a trapezoid, you're thinking about it as a rectangle and a triangle, which I think is a reasonable thing to do. Like the rectangle here would have an area of, let's see, 2 times 8, what is that? 47. So, just kidding, guys. And the rest? What's the area of that triangle there? 32. We get the same thing? Yay. Holden, thank you for reminding us that this is a trapezoid because my question was, oh yeah, 30. Yes, yes. Don't say anything else until you're about to discuss. Will you please discuss with your neighbor? How do you find the area of a trapezoid? There are parentheses. There are parentheses. Okay. Timmy, do you remember by any chance? Of the two bases? So like B1 plus B2 like this? Okay. Times the height. Are we good with this? Give me a push through. Thank you. I guess that all's forgiven. Today, the late 3 for today be known. Does this look familiar? Can we show what the bases look like? Right now, in the orientation of this. How do you know they're vertical? Maybe it's the other ones. Bases are always parallel. And so those are definitely, it's like a trapezoid standing up on its side or something like that. Okay, so we can either do 1/2 base 1 plus base 2 times the height, or we could think about it as. Does this look familiar? M times H? M standing for the. That's interesting. Now that's slope. Median, which would be this length right here. Does it make sense that that length in the middle is the average of the bases And what is this length here?
This value is 6 plus. Yeah, that's 600. That's different ways to think about this problem. You know, none of them you're gonna need for the homework tonight, everything, but at least it's give you a preview of what you're gonna see next. Hopefully it's been comfortable so far. Ready to turn up the notch a little bit? Turn up the heat? If that's a yes. Here we go. Packets.
Sometimes the function's gonna look like this. You're gonna say, I never learned how to take the area out of that. Which is true. I turned up the heat about 8 levels. Yeah. So, but you see the intervals from A to B, and it is a function, the area under the curve. When we say under the curve, we're not talking about like down forever, it's just between the curve and the x-axis. So it's a closed region. So obviously this is not as easy to do as the other ones. So Nico, make sure you're following along here. I need you to just be locked in. Right, Nico? You just gotta be locked in to this. Come on, Nico, you could do it. You could do it, Nico. Yeah, just lock it in. We need to focus in on this one. Okay, so instead of trying to find the area under the curve, what we do is we estimate it by breaking it up into simpler shapes. So you notice that this one, they've broken up the AB interval into 2 sub-intervals. And each one is, does it make sense? Each one is B minus A divided by 2. Each one of those X, like delta X values. And I do want you to notice that the rectangles are not just like a random rectangle within it. In this case, both the heights of each rectangle are determined by one particular side of the sub-interval, specifically the side on the left, right? So if we're looking at this interval, do you see that if you look at the left side, it's the left end of that sub-interval that determines the height. And if you look at this second interval, how high should we make that rectangle is what the question is. So it's always either going to be the left side or the right side, or even sometimes the midpoint. None of this class, but next year you'll see. Sometimes the height of the rectangle is determined by the midpoint. And you can see that, is this a pretty good estimation of the area under the curve? It's terrible. It's really bad. What do you say? It's overestimation or under? It's an underestimation. And if I were to do maybe the right hand, like, would that make sense that the first one, if I were using the right hand side of the sub-interval, would be that high, and then this one, suddenly I have an overestimate. So, but we're just looking for estimates here so far. But of course, we could do this. We could break it up into more intervals, can't we, to get a better approximation of what that area under the curve is. You can see in this case, they're using which side of the sub-interval to define the heights? The right side. And in fact, if I wanted to label the coordinates at this point here, the x-coordinate would be u sub 3, and the y-coordinate would be f of u sub 3. Does that make sense? It sounds a little nasty, but that's what it is, f of u sub 3. Okay. Moving on. Okay, let's see. Do I want to do these? Yeah, let's do this.
Okay, yeah, we can do this. Just the first example. F of x equals
2x. I'm going from 1 to 2. My scale is off. Let's just draw the approximation for now. Let's draw estimate of the area.
Get it? If you could do this. You break up that 1 and 2 to just put a tick mark in the middle. And then from this is called the subinterval. This first subinterval. We go up to the what side of it? Which side? Is it the right side? How do you know? It says use the right endpoint of the subinterval. So we're going to go up here. That is the height of the first subinterval. Come over to make sure I'm just above the first part of that subinterval. You know how to find the area of that crazy shape I just made? I suspect you do. And how many rectangles do I have? Well,
I have it in total in my finish. There's 2. So for this, my second subinterval for right here, I just go up the right side, up until the function, and then over, and just make sure I make a rectangle. It wouldn't make sense for me to go up here. I would definitely not have the concept if I'm doing something like that. And I've seen things like that. You're just making rectangles.
very, very straightforward. Is this a good way to do this problem? Find the area under that curve? It's terrible, but it's a simple way to it's approximately. Would this be difficult to calculate? No, you know that each base is what is this? 1/2, 1/2, and then you're able to get the heights just
Here by saying f of 1.5, and this would be f of 2. I'm sure you can figure that out pretty easily, is my guess.
on to this next example, except I'm gonna make it gnarly. I'm gonna make it this. Ready? 2x. This x squared
Plus 3. Yeah. Yeah, you see that 1 to 2? Let's make that 1 to 8. And see that 4? Oh yeah. Choose a number that's not 7.
6.
6, okay. We're gonna break it up into 6 subintervals. It's unlikely you're gonna have to do this next year, but you will have to do it for your homework. So I want to help you through this. Okay. I'm going to do a terrible job graphing this parabola, but I do know that's a parabola that's been moved up 3. So I'm going to put a 3 here because that's kind of big. And then I'm just going to do this. And then I'm going to need to make sure that I could see 1 and I could see 8. In reality, that 8 is how high? F of 8 would be 67. But it's not the scale. All that's important is the idea. So use left endpoints of the subinterval heights to approximate the area under the curve. Okay. Here we go. So to break this into 6, I'm just going to do this. Are we good with that? I'm just breaking that into 6 like that. Yes. It's saying from 1 thing. That's all we can. If it's like -2, I mean, you don't figure it out. Thank you. Yeah, it has to specify the region. Now, if we would have broken this up into 7 subintervals, these would be really pretty, don't you think? 1, 2, 3, 4, 5, 6, 7, 8. But my goal was to make it as gnarly as possible. And see what you do. You write the expression just to find the height of the first 2 rectangles, and we're using left endpoints here. Let's make sure the first rectangle is okay. Once it's actually the together. what's the area that first?
It was that, what time, no, we're gonna get this on outside.
Maybe directly here, help with this. You see how it's pretty messy numbers. You already found out that the bases of each one of these is how big? The base of each one is how big? Because we know the full thing is 7, and we're breaking that up into 6 pieces, so each one is 7/6, yes? So what we're gonna have is, I'll call this region 1, 2, 3, 4, 5, and 6. So what we need to do is do area of region 1 plus the area of region 2. Oops, I'll stick with Roman numerals now that I started in that direction. Plus area of region 4 plus area of region 5. I wish we would have chosen 3. Okay, here we go. And the first area is what times what? I heard a 4, yes? 4 times what? Are we good with that? And I write the delta x for the set. 7 or 6 times 4. The second one is going to be 7/6 times something, isn't it? Times, what is this point right there? Well, let's see, this number here is 1 plus 7/6, isn't it? And this number here is 1 plus 7/6 times 2, isn't it? Instead of trying to get an actual number and just leaving it as an expression. And this one here is 1 plus 7/6 times 3. Do you see what I'm saying here? Just taking what we're building upon, we're building on that 1 and then adding 7/6 plus another 7/6 plus another 7/6. Kind of like arithmetic. Do you see the arithmetic sequence happening there? There's a common difference, and like for the third one, we had 1 less than what we started with. So the x value there is 1 plus 7/6. So to get the height of this rectangle, I just had to take that number and plug it in to our crazy expression there. Okay. Sorry I made this so hard. Not that sorry though. We're at plus 3, is that right? Is that area of 2? Did I do that right? So the area of region 3, I'm going to start off with 7/6 times 1 plus 7/6 times 2 squared plus 3. Yeah. Plus, sorry for those of you who use this all up for the work that you're already doing. I'm just going to do dot, dot, dot. Should I do dot, dot, dot forever? No, there's an end here until the last one. The last one is going to be 7/6 times 1 plus 7/6 times, how many are we adding? Let's say this is times 1, 2, 3, 4, 5. Is it times 6? Am I getting that right? Because there are 6 of them. Did I do that right? Right, the first one was 7, 6 times 1, the second one was 7, 6 times 2, the third one 7, 6 times 3, etc. Okay, now should I get out my calculator and just plug all that in? You could. Instead, I'm going to simplify this a little bit by first factoring something out, maybe like a 7, 6. Let's do that. 7, 6 times. I'll do brackets just in case. So we have 4 plus 1 plus 7, 6 squared plus 3 plus 1 plus 7, 6 times 2 squared plus 3 plus dot 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 plus 1 plus 7, 6 times 6 squared plus 3 . Now what? Try a little bit, maybe. Let's not do our calculator just yet, because there's some simple stuff that can be done, isn't there? Inside those brackets, you could do 4 plus 3 plus 3. Can't you do that? Can you add those numbers together easily? Let's do it. So, and how many 3s are there? Are there 5 of them? Let's see, there's one that goes with it times 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think there's 6, aren't there? Wait, are we doing left endpoints? 4, 5. I'm so sorry, but the last one is 5. I got a little confused. I switched to right endpoints. This is the last one. I'm so sorry. 1 plus 7, 6 times 5. My apologies. Yeah, so there's 5 of them. So 15 plus 4 is 19, leaving us with 1 plus 7, 6 squared plus 1 plus 7, 6 times 2 squared plus dot 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 plus 1 plus 7, 6 times 5 squared. And now it's maybe a little bit easier to plug into your calculator, but there's one more thing I want you to see if you can simplify. I want you to think about this. For the next 3 minutes, we'll resume at 2:38. Look at that cliffhanger. Cliffhanger, first of the year, finally. Still breaking a long time. You guys exhausted or just easily anticipating this next one? You do stand up and stretch. That's a perfect time to stretch. It's perfectly acceptable. Why we all let's all stand up. Let's just stand up and swing those arms, get the shoulders rolling, stretch your legs. You're like, now's the time for that. Everybody up, come on, everybody up. Unless you just really don't want to stand it. If you really don't want.
Class is over for the next one.
What's that?
I agree.
Class is over for the next.
Yeah, wait, can you like?
We'll
all
call
go
it
down to
a
the
pre-conference,
field?
yeah. Oh, you missed out the 20 minutes before class? We did that. Oh, it's so sad.
Wait,
Wrong,
can you do that on Flex?
Maybe we could do some dancing on the flex day. Oh, that'd be kind of fun. Okay, guys, have a seat. Have a seat.
Let's see the hands off.
I think Zach, I think it is. I can make up your guitar.
Wait, I'll do a solo dance if you take off all of my parties.
A solo dance in front of everyone?
All of my parties are ignored.
It has to last 3 minutes long. And be to Britney Spears. That's so tempting. Should I do it?
Yeah.
If I could, I would, but I'm sorry, it's just not possible. Thank you for the offer, though. You want to just show us a little 10-second demo, though? Just to show what we're missing? You sure? Anybody else? Oh, that's right. I think they've just begun. Just begun. Okay, guys. Again, you can type this into your calculator, or you can realize that there's an easier way to do that using your calculator. What am I thinking of? What?
Yeah.
What is it?
Someone else say it.
It's summation. Aren't we adding up a bunch of stuff? So how can we rewrite this? Because this is definitely 7/6. There's nothing we could do with that. 19, there's nothing we can do with that. But let's write this in sigma notation. On the bottom, we're going to have n equals what? Well, what's the top going to be? It's going to be a 5, isn't it? I see that 5 right there. Is that how we end? So the bottom is going to be n equals 1, because this is 7/6 times 1. So I'm just trying to use a tool that we've done in this class to help us not work so hard with the mini calculations. Now, this is taking a lot of analysis to get here, but what's going to be in that sigma? Like now on the right side of it, I'm going to have to write 1 plus 7/6 n squared. All of that squared, like that. And I believe that is something you could do with your calculator. Do you all know how to input that into your calculator? You have the sigma. Oh, have you not done that in your calculators?
No.
Let's do it. Because I think that you'll agree that so far, this is preferable than to doing all those calculations in your calculator. Talk to the neighbor, see if you can find it. Do you see it? Is it lovely?
You got an answer? That's awesome. That's awesome. I didn't.
Okay, so what do we do? Where do you find sigma? Math. Okay, math, and then we go up, so we don't have to go all the way down, and then, or just type in a 0, right? If you just type 0, I think it'll get there. Look how beautiful that is. It's all set up, ready to go. And we'll use, what letter you want to use? Let's just use X. It's the most easily accessible. You don't have to use N. So X equals 1 up to 5 of. I think I need that 1 plus 7/6 x, and then we just square that. Does that do it? And then hit enter. Great. And now you just take that number, add 19 to it, and then multiply all that by 7/6. And I hope you agree that that's a little bit more pleasant than going through this by hand. To be considered. And I know that's tough. Like, take a moment to discuss where that long expression came from and how you translate it eventually into sigma notation, please. Now, this 4, I think, could be rewritten as 1 plus 7/6 times 0, can't it? Squared plus 3, if you want to fit it in for the rest. But it's perfectly with all the rest. That is our 0 terms. But because that was an outlier, our sigma notation started to with 7/6 and 1. Anything started over here and then that will. What do you think? Can we able to connect the dots like 75% ish or more? I think so. That I know it's a lot. And there are a couple questions that are just annoying if you don't use a calculator with that. So you can do either by hand or use a calculator to get there. But let's finish this up. Remember the goal in calculus is not to approximate the area, but to find the exact area. We've just been approximating, finding estimations, and they've been either underestimates or overestimates. And you could probably guess that you could find the exact area by using how many rectangles? Infinitely many. So what we do is we take this idea. We take this idea and say, let's see what we have here. So same function. We're going from A to B. We're cutting this into n sub intervals. So delta x would be B minus A divided by n. Does that make sense? The base of each one of these rectangles would be B minus A over n, just like the last one was 7/6. And 7 came from 8 minus 1 divided by 6. So what we have is a bunch of rectangles, the height of which is f of u sub I. The base is delta x. And we're going from I equals 1 to n. Now this is an approximation of however many, like if we have 2 rectangles, and we get like 2 right here. And this would be like 1 and that could be 2. What we want to do is take this limit as what happens. Take the limit as what goes to what? I is going to stay with 1. But think about what we want. We want to have an infinite number of rectangles. Which means what's happening? Limit as n approaches infinity. Yeah. You'll see this again next year. We're not going to talk too much about it, but we're going to say, what I'm going to tell you is that this simplifies into a different notation. Notation that looks like this. It's an elongated S. It's called an integral. And it's going to be the integral of f of x. Delta x becomes dx. This is just a delta x that is infinitesimally small. And to define the region, we'll say from A to B. So if you're looking for the area under the curve, this is the expression you're going to put in that area. And we're not going to go over the other people about how we do that. That would be next year. But you're going to see questions on homework that look something like this, using the graphing utility to approximate the area under the graph of f of x to the x-axis between x equals 1 and x equals 5. In other words, evaluate this. So this is the integral from 1 to 5 of x squared dx. It has no real purpose. It's just kind of vestigial remnants from what it comes from. It comes from that delta x. Oh, it tells it. It has to give you a function. Use the value. So visualizing this, we know we have this function, and we're looking for. Does this make sense that this is what we're looking for? That this is exactly what the problem is going to give us? Cool. Let's use a calculator to figure that out. So we'll go back to the calculator. Again. Okay. So first of all, I'm going to graph my function. It's not going to be that one. It's going to be x squared. And I want to be able to see the region. I want to be able to see what I'm looking at. So we're going from 1 to 5. I can't see everything there. So let's change. I'll give you a moment to change the window. I want you to be able to change it such that you see just like what we graphed earlier. That region from 1 to 5. Right? Okay, so the window X min maybe -5. Yeah, -5 is too much, isn't it? Maybe 0. X max 5. 5. Let's give ourselves a little room. 6. But 5 would work too. X min. Oh, sorry, y min 0. I like to have a little bit of a border, so 0 is fine, but I'm gonna put -1. I wouldn't judge you if you put 0 there. If you put 2, I'd be a little concerned about what's going on. But the y max. We know that at 5 it goes up to 25, so something about 30. 30 seems like a nice round number. Okay, so now let's graph it, and we're set up to see it. And you could imagine that area shaded below, correct? Well, it doesn't have to be in your imagination. Let's make it a reality. Let's go to calc. You remember what calc is? And go ahead and finish the problem. Yeah, finish the problem. You could do it now. See which one to choose. You could just type in the number for the lower limit, just type it in, you'd have to like arrow down. It's from 1 to 5, is it? You get it? It is pretty cool. Alright, hopefully you just fell in love with your calculator a little bit more. A little bit more. Right. Do you see something beautiful? You see it? You just type a 1. The number 1. The button right here. So you don't have to arrow down there or anything. You can just type it. Another thing you do is at math. Where do you see where it would be under the math? 1, 9. Well, let's see. I'll just go down so we see it. Oh yeah, it is 9. That's the finite integral. Enter, and then look what it gives you. Look at that. But it doesn't give you the nice visual that the other one does. But you know, so you can put that 1 down there. This is from math, and then it's 9. Math. So, ladies and gentlemen, that's pre-calculus for you. That's it. That's pre-calculus. Good job, folks. You have a few minutes to look at your assignment. I do want you to take a look at the first couple. It's already up. Oh my God. Oh, it's. Yeah. Oh, let me turn off this.